Hi, we have another question, section 4.4 again, number 18. And basically they're constructing a window that has a 16-foot perimeter. So, and what they're trying to do is construct this so that the most light can get through it. So the window is shaped like this. Now, this is X, and this is X. That's given in the problem, okay? And then also, the top part of the window is in the shape of an equilateral triangle. So an equilateral triangle means all sides have the same length, okay? And so that's what an equilateral triangle is. Now, the book gives you a hint how to find the area of an equilateral triangle. It's the square root of 3 over 4 times x squared. It's one of the sides squared. Now, that's a high school geometry concept. They're giving that to you a hint because they don't really expect you to remember that from 10th grade. And so that's what the area of an equilateral triangle's formula is. And so what we're going to try to do is trying to create a window that has the biggest area. Now you think, well, just make the window, keep making the window bigger and bigger and bigger. The problem with it is this part right here, 16-foot perimeter. If you start making it too big, then the perimeter around the window becomes more than 16 feet. So you only have 16 feet to work with. So what we're going to try to do is come up with some kind of a formula that will find the area of the whole thing. But we're going to do this in kind of two stages. We're going to find the area of the rectangle and the equilateral triangle. Now you can't say these are x because they don't tell you that these are x as well. If these were x, it'd be a square, okay? But we can find the length of these things. And how do you do that is you find the perimeter of the three things that you do know, and that's x. So what's left is 16 minus 3x. So this is x, this is x, this is x. So the leftover part, the 16 minus 3x, is for this piece and this piece. But since there's two of them, I have to divide that by 2. So if you do the math on that, that's going to be 16 divided by 2, which is 8. And then minus 3x divided by 2 is a minus 3 over 2x. And that's that side right there. And the reason I need to know that side is because I'm trying to find the area of it. And I'm going to find the area of it by finding the area of the rectangle, which is base times height. And they don't give that to you because they expect you to remember that. And the area of the equilateral triangle, sum of those two things put together. And again, they gave you that right here. So the formula will be base times height for the rectangle. So it'll be x times 8 minus 3 over 2x. That's the rectangle. And then plus the area of the equilateral triangle, which is the square root of 3 over 4 times x squared. And again, we're trying to find the maximum area. Now, this is a section, when they ask for a maximum, minimum on the test, whenever we're doing this semester, they are talking about quadratic. So whatever comes, when they use the word maximum or minimum here, they're wanting you to find the vertex. So in essence, this has to be quadratic. And you may not recognize that as quadratic yet, but once I simplify it a little bit, it will be quadratic. It won't be very pretty, but it will be quadratic. So x times 8 is 8x, distribute. X times negative 3 over 2x squared is a negative 3 over 2x squared. And then plus the square root of 3 over 4x squared. So obviously got the x squared going on. And so it is quadratic. The problem is there's 2x squares, alrighty, and they're not nice numbers in the front. So it's not like a 2x squared plus 3x squared, and I can just add them up and get 5x squared. So here they are x squares, but what I'm going to have to do is I'm going to factor the x squared out because the negative 3 over 2 plus the square root of 3 over 4 cannot be combined. So that's just adding these numbers up. Okay, and then don't forget the plus 8x. Now, I know it's not very nice, but you're not going to go. You don't have to do too much more work. What they're trying to do is figure out what value of x that will produce the maximum, and that occurs at the vertex. So you have to find the vertex that's associated with this. And remember, we have a little formula for that: negative b over 2a. Okay, so you take the opposite of 8, which is negative 8. And then 2 times the a. And a is not just like a negative 2 or anything like that. It's this whole thing right here. So it's negative 3 over 2 plus the square root of 3 over 4. Now, they're not asking for the maximum area. They're just looking for what this x has to be to do it. So really, once I calculate that, that's the answer. Okay. Now, if I want to know what that maximum area is, if they ask, what is the maximum area? Whatever that number is, you have to go back and plug it in here and work it out. And I guess they think they made the problem hard enough. So all you got to do is calculate this. So it's -8 over this. And that is whatever that is will be the length of these x's right here. And if you want to know what the sides of the height of the rectangles are, you would actually have to do this calculation. It doesn't ask that in this particular problem. They just want to know what the value of x has to be to produce a maximum. Okay, and it is a maximum because this number would turn out to be negative at the end. If you take -3 over 2 plus the square root of 3 over 4 and then put it on a calculator, I'm not sure what it is, but this is like -1.5. This one's like 0.4, something like that. And when you combine the -1.5 and plus 0.4, you definitely get a negative number. So the graph is actually going down, so which would produce a maximum. So if this number was a positive, I would have been concerned I made a mistake somewhere, because if that was positive, it'll open up. And if it opens up, there's a minimum down here. Okay, and they're not asking for minimums. So when they ask for maximums, the leading coefficient has to be negative. If they're looking for minimums, the leading coefficient better be positive. If that's not the case, you made a mistake at some point. So, but anyway, I'm not going to do the math here for you. I'll let you take care of that yourself. But I will give you a hint. When you're doing the bottom, when you plug this into a calculator, you're either going to have to do this all at one point and then divide what it is into -8, or you're going to have to use some sets of parentheses to keep it separated. So it's a shame getting all this hard work done and just not being able to use your calculator correctly. So, but anyway, this is problem number 18, section 4.4, and that's it.